All right, welcome back. So in our first video, we created some code to send or to use the Rangefinder. It's important that you know how this code works. So the first thing, remember, we did is we sent a digital write command, making sure that the trigger to this Rangefinder is set to low. We gave a very brief 2 microseconds, so that's 2 millionths of a second delay, just to allow the Arduino just a tiny bit of time to make sure to set that pin to low. Then this is where we actually start the measurement. So we clicked in a trigger pin high, and we sent out a 10 microsecond burst of sound, and then we went to trig pin low. So we have this little chirp of noise going out, and then right after we set it to low, we use the pulse in command, and what this does is says, hey, look on echo pin, which is where that pin is located. For me, it's 13. Wait for it to go high and time how long it takes until it goes high, and then record that time in microseconds in this variable called echo time. So the echo time is going to store how long it took the pulse to go there and back. All right, and then we're serial putting echo time to the screen. Let's see if this is working. I've already uploaded mine. And yep, looks like it's working pretty well. I'm gonna move it closer. I'm pushing it. I'm putting it against my Arduino box, so I have a hard surface. And as I go closer and closer and closer, I get smaller and smaller numbers. Awesome. As I go farther away, I get bigger numbers. Nice. I might try some different stuff. I'm gonna try a round thing in front of it and see how well that works. Oh, so that's pretty close. When it's really close, it works, but when it gets a little bit farther away, it stops working well. So at this point, it's actually, when the sound goes out, it's hitting the round part and then bouncing away from the sensor. So when it's super close, some of that sound bounces back, but most of it bounces away, so it doesn't have a max range very far with that. I'm gonna try something soft like my shirt sleeve and see how well that works. Again, it works okay until I get a little bit farther away, and then the soft shirt sleeve actually absorbs that sound and it starts shooting up to the highest level. Now I'm going to just take it and just aim it across the room just to see what the largest value is that I get. Still getting some reflections. There we go. So when I aim it, I really need to aim into an open space. I was aiming it like towards the computers, and it was bouncing off the computer monitors. So it looks like just under 70,000 is the max value that it'll give. So that's what's called a timeout. So the pulse in, if it doesn't get a pulse back in 70,000 microseconds, it just gives up and leaves and gives up on it. So it can't measure anything more than that. All right, awesome. So I think that's working. Oh, we need to do some work with this. Next thing I want you to do is grab a ruler and set your the front of the Rangefinder exactly 30 centimeters away from a hard object like your Arduino box. And we're going to measure how far. For me, I'm getting these values, which seem to be ranging a little over 1,700 and a little under 1,700. I might go with 1,700 on mine. So I don't know what yours is going to be like exactly, but that's what I'm going to use for mine. So 30 centimeters takes 1,700-ish microseconds. And what we can do is we can take this number and that 30 centimeters and find out how many centimeters away something is per microsecond that it records. To do that, we're going to do some division. So let's click back over. Actually, give me 1 second. All right, so we flip back to our assignment. You'll find this slide in here after the video. And we're going to fill this out real quick. So distance to object, I chose 30 centimeters for my distance. So in here, I'm going to put 30 centimeters on top. And then on bottom, I'm going to put the rangefinder time that I got from that. And for me, I estimated it to be about 1700 microseconds. And this little symbol here is a Greek letter called mu. And this little U with a weird thing on it, that stands for micro. Just like mm is millimeters, mu m would be micrometers. All right, and then so I'm going to do the math real quick. And let's do your math. 30 divided by 1,700. And that gives me this really small number of 0.0176. And that is centimeters per microsecond. I can actually copy and paste this mu from here, actually. I'm going to do that just to put them in here. So I do like having units on my stuff. Microseconds, and then put another one right here. All right. So what this number means is how many centimeters, how far something has to be away per microsecond. So if I get a 1 microsecond reading back, then it's only 0.016 centimeters away. If I get 1,000 microsecond reading back, it's going to be at about 17.6 centimeters. If I get 10,000, it's going to be 176 centimeters. So this number allows me to use the time there and back to be able to figure out what the distance is and calculate it. So I need this number next to my programming. So I'm going to come back over here to the code, and I'm going to enter in a new one. And then let's call this variable, I don't know, target distance. Whoop, except that was done badly. Distance. So target distance is going to equal whatever the echo time is. ECH. Actually, let me copy and paste that so I don't make a mistake, a typo mistake. Control C, Control V. And I'm going to multiply that by the number I got back here on this screen. So that's 0.176. I'm going to come back over here, 0.0176, I think. Let me go check that real quick. Yep, 0.0176. Now yours may be different. So this uses, let's use this first, uses the echo time to calculate target distance. Awesome. So now we've got a variable called target distance. We never made that variable. So if we were to actually, let me hide the console here. If we were to upload this, we would get an error here that says it's not been declared yet. So let's go ahead and declare it, Control C. Now up here, I'm gonna have to do another long variable because I'm working with these microseconds. And I'm gonna do that as target distance right there. And I'm going to give it a starting value of, who cares, 0. It's going to get overwritten right away, so this doesn't actually matter what the starting value is. Control C, Control V. Okay, and now because we can't see this working, so let's do another serial print. I'm going to come up here and steal this serial print, enter, come down here, clean up the indentation so I can keep my code nice and clean looking. And I'm going to actually turn off this serial print because I don't need it right now. So I'm going to do Control/. That'll comment it out. And then I just need to upload this code and fix any errors that might be lingering in the background. Oops. I'm actually glad it did that because that did mess that up. Aerial flow. Let's see what the error says. That's weird. Expected before serial. Oh, did I forget? Ooh, I forgot my semicolons. So if you're watching this and you're like, Mr. How's a semicolon? You were right. I should have had that in there. And then here, I don't actually want to print echo time again. I want to print echo distance. I didn't update that. So Control C, Control V here, so it was echo time. I want target distance in here instead. All right, so now I'm gonna upload this and it might actually work. And then I'll open my serial monitor and we'll see where we are and stuff. This happened to me yesterday as well. It started working again this morning, but like it's not working. So at this point, I think you're gonna be kind of on your own with checking the way your target distance stuff work. So as you go farther away, use your ruler to make sure that it's still measuring accurately as you get closer and farther away to something. And if it's working, great. If not, problem solve it. Figure stuff out. I love this. All right. So now that we've gotten, presumably, I can't tell if mine's working or not, but I think we've gotten our echolocation working, so we can measure the distance of object. Now we just need to control the speaker with it. So to do that, we are going to create a variable. Well, okay, so right now we need to know what our sort of max distance that you're going to use is. So get a feel for how far in front and behind you want to use. You could probably use the lid of your Arduino box as a hard object and get a feel for when the numbers, the distances stay pretty consistent. When you get really far away, it's going to be hard to keep them consistent. So kind of get a feel for how you want your theremin to go, how far you want to be. Once you have that range, then we're going to switch over and we're going to do a map function. So what we're going to map is we're going to map target distance. Right now it has a huge range, or a range of 0 to 30 or whatever it is. So we're going to map target distance, and we're going to map it from whatever range you found. I'm going to say 0. Mine is going to be 0, 40. About 40 centimeters away is about as far as I want my hand to be away. And then we're going to think of what our tone's going to be. So here we're going to map it from distances into the tones. So 0 to 40 is going to map up to, I don't know. Let's just go from 100 hertz. That's a low sound, to 1500. And we can play with those numbers and make them more and less annoying over time. So these first two are the range of values from your rangefinder. So what's the high and the small, the low and the high range. And then these two are going to be the tones that they produce. So the high and low of the tones that they're going to produce later. All right, so this converts distances to tones. Okay. And now remember, Arduino's stupid, so when it does the mapping, it's going to get this new number somewhere between 100 and 1500 and then forget it instantly. So we got to put it somewhere. So back over here at the beginning, we're going to create a variable called, I don't know, I can't use the word tone because it's used by Arduino. Sound. I don't know, sounds fine to me. Whatever you want to call it is fine. So I'm going to make a variable called sound, and then I'm going to go Control C and come up here and do, at this point, an integer is just fine, equals, and we're going to start out at our low sound of 100, and then let's put in this Control V. All right, now we've got a sound going, and I think actually before we do this, we need to limit our distance here because our target distance could be something out of control. So let's do that. Let's say if target distance, so parentheses, is greater than 40, so if it's more than 40 centimeters, that's the max we want to measure. Yours might not be 40, it might be whatever you want it to be, so let that number be what you want it to be. Then a curly brace, enter. And then we're just going to say if it's greater than 40, we just want to set it to 40. So target distance equal to 40. Sets the target distance back to 40. Okay, so if the target distance is greater than 40, set it back to 40. This creates a maximum, let's put that here actually, creates a max value for the target distance. Okay, and that's a 40. You can change this. If you change this to 50, change this to 50. In fact, you could even create a variable called max distance, save that up here as 40, and then put max distance in all these places where there's 40 here, here, and here. That way, as you're editing your code and you want to change the max distance, you could change it up at the top once instead of changing it 4 or 5 times. All right, at this point, we just need to use the tone command now. And then, so remember on the tone command, to use a tone, we need to use the tone command. So I'm going to open up some space down here under sound. And then, oh, actually we should do a serial print. Let's come down here and grab this serial print real quick to make sure this is working. And pop this right down here. And then I'm going to do a control slash up here because I know that one's working. And then I'm going to upload this and just check to make sure that my, oops, I don't want that. Delete target distance and put in sound now. We want to see if our sound is working. So if everything is working just fine, when you move your hand closer and farther away from the rangefinder, the numbers shouldn't be from 0 to 40 centimeters or whatever it is. They should be between 100 and 1500 or whatever values you put here to make the sound. All right, once you have that working, our next step is to actually send the sound to the speaker, and we're going to use that using the tone command. So tone, and here we're going to go speaker pin. So that's the pin that the speaker's plugged into the Arduino on. I'm going to check mine, and we need to make this variable real quick. So I'm going to Control C, come up here. Oh, actually, I already made it. So int speaker pin equals, in my case, 7 was what it equaled. Okay, I did that a minute ago, and yeah, don't worry about it. And then, so I'm going to come down here after we've done that. We told it where to send the sound to pin 7. And now we need to tell it what to send. And in this case, our sound values are in the variable called sound. So I'm going to put that in next, semicolon, slash, slash, and this sends the tone to the speaker. All right. At this point, my friends, you're ready to try it on your Arduino. So upload that code, see if it works. Hopefully when you move your hand away, now that it should actually make sound. Remember, you'll have to hold down the button up by the speaker in order for it to make sound. That way it's not, everybody's not making annoying sound all the time. All right, have a good one, my friends. I hope this was a fun exercise. You have now learned how to use the rangefinder. So in the future, you need to use it. You can look back at this code and figure out how to make everything work.